Imagine downloading your favorite movie in just seconds instead of hours. This remarkable speed is possible thanks to file compression, one of computing's most ingenious innovations. File compression is the process of reducing a file's size without losing essential information. Every day, we benefit from compression when we send emails, browse websites, or stream videos. But how exactly do computers perform this digital magic trick? At its core, compression works by identifying and eliminating redundancies in data. Consider a simple example. Instead of writing "st" as 80a, we could more efficiently express it as 10a's. This fundamental principle drives all compression algorithms. Computers use two main approaches to compression: lossless and lossy. Lossless compression preserves every bit of the original data, allowing for perfect reconstruction. This method is essential for text documents, spreadsheets, and program files, where even minor alterations could cause corruption. One popular lossless technique is Huffman coding, which assigns shorter codes to frequently occurring characters and longer codes to rare ones. For instance, in English text, the letter E appears more often than Z, so E receives a shorter code. This simple yet powerful approach can reduce file sizes by 20 to 50%. Another clever method is dictionary-based compression, used in formats like zip. The algorithm builds a dictionary of repeated sequences and replaces them with shorter references. When you compress a folder containing similar files, the algorithm identifies shared patterns across all files, achieving even greater space savings. Lossy compression takes a different approach by permanently discarding some data deemed less important to human perception. This technique powers formats like JPEG for images and MP3 for audio. In a JPEG image, the algorithm might preserve detailed information in areas where the human eye is sensitive to changes, while reducing precision in less noticeable regions. For audio compression, algorithms exploit psychoacoustic principles. They remove sounds masked by louder ones or frequencies beyond human hearing range. This selective data removal can shrink files to 1/10 of their original size while maintaining acceptable quality. Modern compression often combines multiple techniques. For example, video compression first eliminates redundant information between frames, then applies lossy compression to each frame, and finally uses lossless methods to package everything efficiently. The impact of these compression techniques extends far beyond convenience. They enable faster internet speeds, reduce storage costs, and make cloud computing economically viable. Without compression, streaming services would require vastly more bandwidth, and smartphones would store fewer photos and applications. As data volumes continue to grow exponentially, compression algorithms keep evolving. Researchers develop increasingly sophisticated methods that analyze content semantically, predict patterns using machine learning, and adapt to specific types of data. These advances ensure that as our digital world expands, we can continue to store, transmit, and access information efficiently. File compression represents one of computing's most elegant solutions, finding order within chaos and simplicity within complexity. This invisible technology shapes our digital experience, making the seemingly impossible not just possible, but wonderfully ordinary.